Okay, in this section what I want to talk about is basically a couple of things that you need to monitor when you're starting up a servo system, or if you're controlling a servo system state. Basically an axis on, off, controls reset and stuff of that nature. As you've seen, we basically put like a state machine in, like a mini state machine, not necessarily nothing complex, something very, very simple, but something that would track its position. So what I've done too is I've added alias stuff instead of having HMI, basically just aliased it to real world inputs. So I've incorporated a analog car, a input card as well. So one thing I want to talk about is there's a couple things, so if you're starting a system, you want to obviously monitor the communications to basically to the Kinetic 6000. So with that said, it's important to monitor the I/O status down here, the Servo network. So what is the easiest way to do that? Now you can actually set up a message block, and you can set up a message block to see exactly where the Servo ring is, like 1, 2, 3, and 4, or you can just monitor this fault ring right here, which is the simplest thing to do, which is associated with this axis. So every time you make an axis, it will have this Servo fault ring in, at least if you're using a Kinetic 6000. And I'll show you. I'll drop the network real quick and show you what it does. So with that said, now the system knows that it cannot, start the process, and it also needs to know that it's grouped. So meaning that if the Servo is actually, or if the motion group is healthy. So just saying that the motion group is healthy doesn't mean you're communicating to it. As you see, I just dropped the network and I still had a motion group synced. So that means the motion group was happy and it was able to run. So again, you don't want to start the system, and you want to make sure you have some blocking bits in there to make sure that you have good communication. You have your motion group synced, which means you have your motion group set up properly, and then you can start your system. So therefore, if we start the system now, which I'll go ahead and press the start button, basically then it goes in and does the functions it's supposed to be doing. Now my state machine, again, right here went into a state 2, which in a state 2 I can home, I can do whatever I want. I can cut it on, like in this case I can cut it on and it go to state 4. I monitor states again. Like every situation, I monitor like the faults, the fault state. Right here, again, if it was in a fault state, then I would not allow it to go into the on state. I wouldn't cut the drive on. And therefore, down in the very, very bottom, I'd like to show you what I actually do with the state machine. Is in first scan, like say for instance right now we're in a state of 4. Okay, so let's just cut the turn the program into program mode and cut it right back on, like we just cycled the power. So the first scan bit is something that I always put in to take the servo control right back to a 0, because in the case of the processor, say the key switch got turned, the power got cycled, or in the case of you just put it in program mode, then you're in an uncontrolled state. You're in an uncontrolled pattern where the system cannot control the servo or the motion that is being taken place. So therefore you want to actually throw the controls into a 0 state, or a safe state, in other words. The same thing corresponds with the Servo ring fault, and again I'll show you. I'll pull the Servo and show you that the fault happens. Again, I throw it into throw the state machine into a 0. I also monitor the servo controller fault. So if the servo controller has a fault, it will do the same exact thing. Okay, so even though the axis, and you see the axis kind of resets itself after as soon as everything goes back healthy. So how do I actually get the faults? So this is a tag that is automatically generated when you make an axis and you have that axis attached to a physical real-world hardware. So you do get this, and this is again only if you're on the Serco's network, but you get this bit. This and you get the group as soon as you actually have the axes in a motion group and they are synced. So if the motion group is not synced for some reason, I will throw the state machine into a 0 as well. Okay, so with that said, how do I get the servo controller fault bit? Okay, so the servo controller fault bit is I actually get I do a GSV, which is a get system value. I look at the module, which in the class I look at the module. That means I'm looking all the way in my IO tree. I'm looking the instance I'm looking at the actual servo controller itself. So the Kinetic 6000 in my case. I'm looking at that actual module, that servo drive. The attribute I'm getting is a fault code. Then I made this tag. This is obviously the fault code, right? So it's basically a dent, and it throws in the value that it's currently in. Now, if that value is not equal to 0, then it will trigger this bit, which then again I use to say I want to throw the state machine into a 0. Therefore, it is safe to say that if my kinetics trips out or my kinetics is not in a good state, that I should be able to put that up here as well. Now the reason being is because I don't want to be able to control it out of a out of a state. So let's just say if it faulted out, I don't want to be able to control it out of that same state, right? Unless everything is happy. I don't want to be able to like push this button right now and start the system and it can, have the state machine thinking it can control something when it can't. So again, when my bits come back good, then I'm able to again start the system. When I start the system, I'm able to cut the servo on, and I'll come down here and actually increment a run. So we'll increment a run real quick. So the system does run. So everything's healthy, right? So again, if I told it to run and I lost servo control, then I want my system to be able to recover. So now, as soon as that Serco's ring comes back, I want to be able to come back and toggle this bit. See, my state machine is in a state of 0. So now I start it right back, and it goes to a 4 because I had my switch on already for my on. So as soon as it goes to a 4, I'm able to control it again. So you see there's things that you can put in place to double check to make sure that you have, and I'm not saying that this is the tried and true way to do things. I'm giving you options. I'm trying to open your eyes to say, you should actually monitor the status of your I/O. You should monitor your status of your motion group. You should monitor your status of your axis you're controlling. You should monitor everything that is pertinent to the machine actually running, and or the axis you're trying to control actually working and function properly. You should control every component in that chain. So meaning if there's a Serco's, so let's just talk about this for just a second. I'm sorry, I dropped my screwdriver. So what I'm going to show you is like, say for in our instance, our axis 01, right? So we want to look at and make sure our motion group our motion group is healthy, right? So that's one thing we want to look at. We want to make sure our I/O tree is good. So we want to make sure everything is good in our I/O tree, which is our Sercos, which again we monitor that bit. Then we want to make sure our actual kinetics 6000 is good. So these are all three things that tie in. The motion group is obviously where the axis 1 is housed, is in. The motion group itself is, one of the main features, right? Then your kinetics is your communication through your backplane to the kinetic, or the Sercos, I'm sorry, is the Sercos is your communication from your backplane to your actual kinetics drive. So you want to monitor that because you want to monitor the communications. You want to monitor the Kinetics 6000 because that is, again, the controller, the servo drive itself that is going to be doing the functions to the servo. It's going to be controlling it. So you want to make sure you control, or you monitor all three of these when you're controlling it, or I should say when you're understanding how your state machine should work, or how your control should work. So that I say state machine, but you want to make sure your controls work properly. You don't have to have any states at all, but you do have to have proper controls for your system to work properly. And again, I just wanted to show some clarification behind this, because I know throughout this training we've basically laid in a foundation, and we've laid in several different elements, and not once I was trying to add everything up to get to this point so that we can, get to this and show exactly some key components that need to work. And I'm not saying that you're written in stone that you have to do a GSV, or you have to do this bit, or you have to do that bit. What I want you to understand is you do have to monitor, if you want a system to work correctly, you do have to monitor the motion group, the axis status, the communication. You want to make sure you're talking, right? So would it be fair to say that you could do a GSV and monitor the Sercos, right? Could you do the same thing here as far as getting the Serco status, and then saying if the Serco status isn't equal to, in this case it would be, we could compare it, right, just like we did, and we could say if not equal to, which in this case, this is our basic healthy function, our healthy status, right? If it's not equal to that, then we could just come down here and say Serco's fault, right? Serco's ring fault. It's simple, just a simple bit, right? So, I mean, what I'm trying to do is to show you there's 100 different ways to do this stuff. So, and you see right here, so if I pull the cable again, it's going to fault out, right? So you see it's not equal to that. Now, as soon as it comes back live, it comes back healthy, then it will come back and show that it's healthy. So there's 100 different ways, and I'm not using this bit, I just made it. But I wanted to show you that and see that this ring is really what's true. Did you see that? This bit is healthier to use than what I just showed you, because let's put the two side by side. If I pull the cable again, I get a fault here for this is the actual axis bit coming from the axis itself. This is a Serco's ring fault coming from the axis, this level right here. Right? This in that token is a GSV looking directly at that module. So it's going to fault out if it does not equal the satisfied state, which in that case is the healthy state. Now this is going to come in first. This is going to come in happy first. It's going to think it's healthy, but this is not actually healthy until it goes 1, 2, 3, 4. That's when this ring will come in and say it's not faulted. So now the system is healthy, it's able to run. So in my opinion, it would not be, this section down here, 16 and 17, would not be something that you could do to run and not monitor this. This bit actually comes with the axis, and I'll show you that. If I come right here to axis 1 and I monitor that, and I go to my, this is all the tags that come with my axis, right? If I go down to Serco's, which in my case I'm in alphabetical order because I did this right here, then I go to Serco's ring fault. I look at my Serco's ring fault. Now let's look at both of these bits. So the only one that comes in is the Serco's ring. So I pulled the cable again. So you see that comes in, and it's a fault right now. Now it will transition when it's happy. It goes 1, 2, 3, 4. It will come back as a 0, and that means it's healthy. So it's a perfect element to use that bit to show that the control of the system, as far as what you need to do. And that's the reason we use action statuses and stuff of that nature, so you actually understand exactly what the system understands where it's at in any given place. So you're not doing any fault resets. You're not doing anything you don't need to do in any given time. So with that said, I'll go ahead and conclude this video. I know it kind of ran a little bit long, but I wanted to kind of stress the fact of what are some pertinent things that you need to understand as far as like elements. What are crucial elements that you need to understand when you're trying to start up a servo, and you don't want to actually be able to control it at any given time if you don't have the control to talk all the way through your hardware. So you need to monitor this stuff and make sure that you're aware of what's going on, and your system is aware of what's going on. So how do you do that? You obviously use the components that are given to you. So it's my job in this course to show you a couple, or open your eyes to a couple different elements that you can use. So hopefully that was done, and again, if you have any questions, feel free to reach out to me. I don't mind answering any questions, and again, hope you're enjoying the course, and thank you again for being part of it. Again, this is this something I'm trying to do to make sure that a good foundation is given. So thank you again, and we'll have another video.